Hello everyone. In this video, we will understand about programming paradigm and structure of C program. Programming paradigm is basically a way we program, how we program a given problem. There are various programming languages and each one of them has their own methodologies, theories, practices and standards. Now these programming languages, they can be broadly classified into high level language and a low level languages. Low level languages, they are native to the computer system and they are written in a computer readable format. By that we mean that these programs are written in terms of zeros and ones. Okay, so it is also called as a binary language. It is a language that is understood by a computer system. So examples of such languages are assembly level language and a machine language. The other classification of programming languages are high level languages. These, when we write program in these languages, they must be translated. They must be translated. Obviously, when a person knows his local language, for example, if a person knows Hindi, and he is talking to someone who does not know Hindi but he knows French. Okay, now there must be some translator in between who translates whatever this person tells into his own language. The same thing happens with the computer system too. Since the computer does not understand any of the high level languages, the programs written in these languages are translated. Therefore, we have something called as compilation. Okay, this compiler, it basically translates the program that is written in a high level language to a binary language or a machine code. Further, these high level languages are classified into procedural, non-procedural and problem oriented. Right? Now let us have a look at a basic structure of a C program. Every programming languages has their own structure. Okay, as if you observe in C++ or in Java, we first write classes, then we create instance of those classes which are called as objects. But in case of C, it is procedural language. Okay, so we don't have any objects here. We straight away start with preprocessor directives. This is the first statement in our program. Then we have something called as global declarations. Then comes the main. Inside the main we have local definitions, statements, the return statement and the end of main. So you have to observe cleanly here. The preprocessor directives, as the name itself tells, these statements direct the compiler, or it's also called as a preprocessor. A component of a compiler is a preprocessor. Now how are we going to have such statement? We write it as hash followed by include followed by angle bracket stdio.h closing angle bracket. So this is a very first statement, first line that is included in our C program, all the preprocessor directives. Here stdio.h, it basically means a printf, the declarations and definitions of printf and scanf functions that we use in our program. Okay, the next one is a global declaration. Now given a problem, you can divide the problem into multiple modules. If those modules are using a common variables, we can declare them globally. So this here, it is here you declare the variables globally. The next one is beginning of the program. So here it is a point where your processor starts executing a program. This is a return value, that is what value you are meant to return to a program that has called. Then we have a keyword called main followed by opening bracket and a closing bracket. Then we have the opening parenthesis. Inside this block, opening and closing parenthesis, in this block we have local definitions and statements. local definitions, it includes declaring the variables. Then statements include the processing statements. Okay, we shall just have a look at the example. So here I have a preprocessor directive. I'll have hash include stdio.h. I will not use any of the global declarations. I will straight away have int main. I will have a statement printf hello world. Okay, so before closing I will just have return 0. So this is how a simple C program to print a hello world looks like. So this is a preprocessor directive. Then we have a main with a return value. You can as well write this statement, the main statement, as void main, right? It is basically, now what does this return type tell? It so happens that your operating system basically calls this particular program. So let me name this program as test.c. It is the operating system that calls this test.c. Once completing, this test.c should return back to the operating system. It should return back to the operating system. Now it depends upon how the program has coded this test.c, whether he wants to return something to the operating system or he wants to return 0. In case if at all he wants to return some value, let it be 0 also, he includes this return statement int. Now what he wants to return back? He wants to return back this value called 0. Now if at all it's coded as void main, if the test.c has been coded as void main, it means this particular program has to return nothing to the operating system. Once it terminates, the operating system takes back the resources that are allocated to this particular program and finishes its execution, right? So preprocessor directives, they tell the processor to look for a special code libraries like your printf and scanf, and prepare the code for translation into a machine language. Global declared variables, if at all you have modules in your program and you want the variables to be visible for all the modules, we have something called as globally declared variables. Now when we have this is a starting point where your program begins its execution. This main has two main sections. One is the local definitions and statements, right? So local definitions describes the data that will be used throughout the program, what all variables you need, what is your data type, etc. And statements, these basically includes the statements that is required for a system to perform some useful task. I mean to tell, it is processing. Okay, now there are two things that you should know. One is, what is the difference between declaration and definition, right? So declaration is basically describing the type of data object to the compiler, okay, but however you are not allocating any space for it. Now definition, it means declaration of the data object, and you are also allocating the space to hold a particular data object, right? So usually what we do in this local definition is that we declare a variable, okay, by specifying its data type, right? When the compilation is done, your compiler will allocate appropriate space to those variables depending upon its data type. Okay, now we shall just have a look at how your program gets compiled and how it is executed in your system. So through the text editor we write the program, right? We write the program using this text editor. There are various editors available, like in Linux operating system we have vi editor, we have gedit text editor, right? And in Windows we have Notepad, we have WordPad, etc. But however, if you observe nowadays, we have something called as IDE, which stands for Integrated Development Environment, wherein you have editor, you have compiler, you have everything in under one roof. Okay, so basically an editor is a place, it's a place wherein I write my programs, Okay, so through the text editor I write the program as we just wrote, correct? I include all the necessary statements as per the syntax of the language, right? Once this is done, I save this program. Okay, I save this program as first.c, and this is called as a source code. This is called as a source code. Now this first.c, it gets saved into my hard disk. Okay, now it is written in a high level language. As discussed previously, any program that is written in a high level language must be translated. So next, so how do you translate? We translate it using a compiler. Again, there are various compilers available. You have TurboC compiler, you have GCC compiler, you have CC compiler, you have C++ compiler, etc. Okay, the compiler does two things. One is it will check for mistakes. Okay, so it will find out if the program that you have written in a high level language is error free. Okay, this is the first thing that it does. And second one is the process of translation. Right, now after this, if at all your program is free from mistakes and you have followed all the rules of the language in order to write the program, then this compiler, it will perform translation. Okay, translate the program from high level language into binary code, into a machine level language. So if you observe, it's made up of zeros and ones. Okay, so this is called as an object code. Fine. In case of Windows operating system, this will be something like a.exe. In case of Linux operating system, it will be a.out. So what does this mean? These are object codes. Okay, these files constitute the object code. Now after this, we have something called as linker and loader. In this program, we have something like this, right? #include stdio.h. Now this object code must be linked with this linker and loader, right? This object code, it must be linked with these header files. So we have something like this. The output of this object code, when it is passed through linker and loader, will get one more file, and this file is called as executable code. Usually what happens is, we do not pass explicitly through these system softwares. It is in fact inbuilt in the compiler itself, right? We will not be able to visualize this loader and linker. Straight away, once we compile, we get these executable files, right? So once we have this executable file, we can run it, okay, which is called as a process of execution. Now how do we run it? In case of Linux operating system, we use ./a.out. In case of Windows, we just give a.exe. Once this is done, we can see the results that is printed on your standard output, that is your monitor. So we can see the results, right? So the main steps in the process of compiling and running a program is The first step is writing the program and saving it into with its name. The second one is a process of compilation, right? The next step is execution. The next step is execution, right? Now coming to features of C language. It's procedural, right? It follows in order a set of commands, right? So you give the instructions one by one, and your system, it executes these instructions in the same order. These instructions are made up of commands. Fine. It's fast and efficient because of its design. Fine. It has a rich set of operators. You can have various modules, right? So it's basically fast and efficient. Modularity, as we discussed, the larger program can be broken down into modules, and in case of C, we call these modules as functions. We call these as functions. It is statically typed. Okay, so here the type of a variable is known at the compile time itself. Some of the programming languages are not statically typed. That means when you are running the program, at that moment the type of a variable is known. This is one of the reason why your C is fast. Okay, it is general purpose language. Using C programming, you can write programs across various application domains. Okay, it has rich set of built-in operators. Take any operations with respect to arithmetic or logical or relational, you can carry it out using this language. Libraries, again, it supports various macros and functions to carry out any type of problem, in order to solve any type of problem. It's also called as a middle level language because C has features of assembly level language and high level language, right? Portability, it runs anywhere with C compiler. If at all you have a C compiler and you have written C program in some other platform, you can very surely execute on that machine. It is easy to extend. C supports user-defined functions, and you can extend the program to any extent. Fine. Thank you for watching.